Welcome to episode 11 of Meet the GIMP. Today I'll try to cover the RAW conversion tool UFRAW. You can find it at ufraw.sourceforge.net, and there's also a lot of information and links for downloading it and how to install it and a user guide and so on. You find there in the color management a lot of information where to get the color profiles and so on. Personally, I haven't used UFRAW for quite a while because I do my RAW conversion with Bibble Raw, and I was by preparing for this show here I was blown away how far UFRAW is grown in the time I'm working with Bibble. And I don't think that today I would pay for Bibble Raw. UFRAW has the stuff to do the RAW conversion. Bibble has some advantages with organizing pictures and so on, but I really don't use that a lot. For understanding why RAW converting has sometimes big advantages about in-camera JPEG processing, we have first to understand how a digital camera works. Instead of a film... Oh, by the way, as you perhaps know, I'm a professional teacher, and a teacher can't live without a blackboard, and so I've made myself here a blackboard. Let's take the yellow chalk and draw the sensor plane. In a digital camera there's no film, and in the place where the film would be there's a piece of silicon, and it's called the sensor. And we can not really discuss what's working on the sensor, but I can steal an analogy by Chris Marquardt. And he has in his cupboard some buckets. These buckets sit on the sensor plane, and they collect light. When the light drops into these buckets, it is stored in the buckets in form of electrons. And below these buckets, or sensor pits as they are called, is a kind of electronic with dipsticks, and these dipsticks touch into the buckets and translate these electrons into a lot of numbers, and they drain the buckets. This lot of numbers is shoveled away as data into the camera, and the camera makes a picture out of it. This picture would be black and white, because we have measured the amount of light in each of these buckets or pixels. But your digital camera can record colored light, and for that there are filters above each of these buckets. One is red, one is green, one is blue, and the fourth one is again green. These filters are arranged in a kind of checkboard pattern, and it's called a Bayer pattern after the guy at Kodak who invented it. The green photosites are double the number of the red or of the blue ones, because our eyes are far more sensible for green light than for blue or for red light. And when now the light comes in, the green filter filters everything out except green, and the blue and the red one filter their light out, and we get only the amount of light in there. So this colored light, I hope no real physicist hears this, There is no colored light and no colored electrons, but these electrons are again converted into a lot of numbers and drained and taken away into the camera. And there they are processed. Now in the camera is a lot of numbers. These numbers are called raw data. They are in a different format and have a different meaning in each camera. Not even each camera manufacturer has the same raw format in each camera. They are different and dependent on the sensor design. We want to have RGB data, information about the amount of red, green and blue in each pixel of the image. And so somehow these raw data have to be translated to RGB data. And this is raw conversion. It can be done in camera. The camera has a little microprocessor in it. It's a computer you would have killed for 20 years ago or even 10 years ago, and it is very powerful and very fast in image processing. But all the raw data is lost after you have converted your image to RGB, say to a JPEG, and compressed this after that. And for doing it later with a computer, you need the information how the raw data is to be converted to RGB data. And for that there is a standard. It's an agreement between all the camera and printer and other optical devices manufacturers. This standard is called ICC color profile. With an ICC color profile you get the recipe how to convert the raw data to the RGB data. Some manufacturers are very open with their ICC color profiles. They give the information to third-party coders and to open source programmers, but some are quite secret about that. But somewhere they have to publish these ICC color profiles, because their raw converters and other third-party programs which can work with that camera need this. And so if you want to look for your ICC color profile for your camera, get your camera software, the software for Windows or for Mac, and look on that CD for a file with the extension ICC or IC something. I went the easy way and took my file for my D200 from a website which was mentioned on the UFRAW homepage. In case that you haven't noticed it, this presentation here was entirely done with the GIMP. UFRAW can be run in a standalone mode or as a plug-in in GIMP. I haven't installed it as a plug-in. It didn't run on the first try, and I didn't want to put too much time into it. I'll see into it when I have installed GIMP 2.4. Then I'll cover that again. But the functionality of the program is the same if you start it as a independent program or from GIMP. It starts as an independent program with a selection tool here with a file selection, and all the raw images are pre-selected, and I'll open this one here. This is the main window of UFRAW. You see here the preview, and there you see this image is a bit tricky and requires RAW. Here you see the raw histogram, the histogram of the raw image. Here the live histogram, which is the output, the histogram of the output, and in between are things to switch on and off. You can hide the histogram here to get room here. I doubt that you'll need that. On this screen here, 800 by 600, I'll have to hide either the raw histogram or the live histogram. Let's start with setting this up. There is a option here, color management. I have to go to this option first, and here you see 3 selectable color profiles, and we start with the camera profile, the input ICC profile, and for that I open this one here. I got it from the internet. It's a profile for my Nikon D200. You open it, and when you look at the histogram here, it has changed. Now I have the translation curves for the Nikon D200 chip and not sRGB. This color matrix is an option which I really don't know what it really does, but I got better results by setting it. It's a thing to be researched. And gamma has to be set for this color profile to 0.45 and the linearity to 0.01 or 0.2. You can play with that and get different results. And you see the image has changed a bit. As file output, I'll use sRGB, and also as a display I have my display on sRGB. I haven't up to now managed to get here a real color profiled system. Let's look around a bit. Here is save as and save. They do exactly what they are labeled for. Save saves your image as a PPM file, and save as gives you an option to save it as JPEG or in a different file type. Options gives you a lot of different information about the program, and you can control the color profiles. You can see the configuration in XML format if you want. You can see a log, and here is the UF-RAW about screen. I have contacted Udi Fuchs, who has written this thing, but I haven't heard from him up to now. This here sets the way the exposure is controlled. You can slide this down and up to get the exposure higher or lower. And here's always this button to get the default values back. This is a nice thing if you have blown out highlights in your image. This is for soft details in the highlights. This light bulb here gives you sharp details in the highlight, tries to do that. And this simply cuts the highlights off, and it doesn't try to go back to somewhere. This here is switches between strictly digital behavior, ramp up and then click, empty, that's the end, or like film, where it's a gradual where it's a gradual step into white, fully white. This here gives you an automatic best guess. Let's do that. Not exactly what I had intended, so reset. I'll leave that alone here for the beginning. The first option, the first tab here, covers white balancing. And you can choose here to take the white balance from the camera. The camera stores the white balance information in the raw file, and you can take different white balances here, say fluorescent light, wasn't right, or direct sunlight, or you can set the exact Kelvin number here. I start the raw conversion by adjusting the exposure, and I go to full overexposure here, 3 values up, 3 stops overexposure from the settings of the camera. And now you see what's on there. It's a picture of a white wall where I stood in front of a banister, and behind me was a window, and light coming in from different windows in this wall, and from lamps overhead. And so you have here a lot of shadows, and I made 2 blunders here by taking this picture. First, I forgot that I had the exposure compensation switched on. The picture was underexposed by 1 stop, and then I forgot to correct for the white wall, and the camera thought about this wall as 18% gray, and so this picture is badly underexposed, and I want to see what I can salvage here. So the first step was blowing the exposure as high as possible in this step, and you see I've got quite a definition here. This step can be reversed all the time as long as you not click on save. No information is changed, and after that the raw file, the NEF file, is still there, and you can repeat this process over and over until you have the desired result. You are not losing information, you're just selecting information from the raw file to go into this 8-bit output file. Okay, first step, white balance. Here I can choose the camera white balance here. This was the picture as seen as by the camera, or I can go here for some presets. An automatic white balance gives me this, not very convincing, and I can select here cloudy. That could be the right one, not really. Shade, also not really. Let's do this by hand here. I can select an area which I want to define as white, and let's start with this one here. I just pulled this rectangle open, and now I click on this eyedropper here, and now this is neutral gray in the average, and the rest of the image is accordingly changed. You see here the white balance temperature and green component values. I could change them by hand. Also here these channel multipliers, but I'll leave that alone. Just try this, experiment with this, and you'll find out a lot about that. On this page is another nice thing, a kind of noise reduction, and I can zoom into the image to a maximum of 50%. I don't know why this doesn't go up to 100. And now you see here this image is a bit noisy. And when I pull this up, the noise is less and less. And as I have no fine details here, I can go quite high with this noise reduction. And I think this will be good. Okay, back to 12% for the full view. Oh, by the way, all the time you can see here the output, the histogram that will be in the output file. On the next tab is the base curve. I'll leave this alone. Here you can set a curve which you will use for all your images or for a set of images. You can save this curve and load this curve. Here are some presets: a manual curve, linear curve, custom curve, and the built-in camera curve. Nikon cameras have a built-in camera curve which is stored in the raw file and used by the camera. And I could change that curve and download it to the camera, but I haven't done that, and so I'll leave this here alone. There is a use for it if you apply the same change over and over again in a series of images. Just make a base curve for that and do the fine-tuning in the other tabs here. This we had, color management, leave it alone. And here is the real stuff. Here I can set the black point, the white point, and I can set, like in the curves tool in GIMP, the contrast and the distribution of bright and dark pixels. First, on the top with this slider I can adjust the saturation. I'm fine with this here. And here I have two automatic buttons. These gears here are a symbol in this program for automatic. And let me try this here. Black point. You see the curve, the bottom of the curve, starts now at the darkest point in the image. You see here the left shoulder of our histogram is directly here on the right. And I set this automatic too, and the camera the program tries to flatten the histogram to get most possible even distribution. Okay, it's a good start here for this image, and let me try to make this a bit better. I just go down with the black point a bit again, and I'll make this even steeper. Now I'm changing the white point, and here you can see the area which is covered by the histogram gets bigger and bigger. I have here some information about overexposed, underexposed pixels, and there are none in all three color channels. Well, it's quite a lot of information there. Now let's try for a good looking curve here. Now that I see this image the first time after I've looked through the viewfinder, I'm a bit disappointed. I doubt that we'll see the wall, and I even doubt that I will do the full post-processing on this. But let's finish this here. I can save also these settings here, the curve, and reload it when I have a series of images. And UFRAW keeps this curve as a default for the next image in the same session. rotation can only be done in 90-degree steps. You see it here. Or you can flip the image in the two directions here. Cropping is done by pulling the border into the image. Try this again. Here it is. And so you can do a crop and get smaller files. And again, clicking on this here gets all the changes in this tab here undone. And on the last tab here is the EXIF information, which can be read but not be written into, and so it's not quite interesting here in this case. I think I have covered the basic stuff with UFRAW, and if you have questions left, ask them, write me a mail at info@meetthegimp.org, or come to the website meetthegimp.org and leave a comment on the blog. Last time I've said that I had so much comments that I couldn't answer all of them, and you get so scared away that I've got one comment on the last show. Hi Norman. I'll try to look for another picture in one of the next shows and start a whole post-processing, starting with UFRAW and going then into the GIMP. Now there's a last thing to be done. This image has to be saved. Now I click to the Save As button, and I get this dialog here. I want to save it as a 8-bit TIFF file. You see here the name is already chosen. I can take here, look for another folder. Let me pull this in again, otherwise I can't reach the bottom part here. And I can set some output options. I can shrink the image, I don't want that. I can select the file format, I can set zip compression for the TIFF files. I even can select a JPEG output, set the compression level, set if I want to embed the EXIF data, and here is an option I haven't really explored up to now. I set it to also create an ID file, and I don't want to overwrite existing files without asking, no thank you, and now I just click on Save. Let's look what's happening. Somewhere the computer is working. Here, you see the progress bar here. And now it's gone. UFRAW is a bit rude by ending the program just after the success, the image, just after successfully saving the image, the window closes and you are back to the selecting window here. Now I quit the program and let's have a look. This here is the TIFF file. You see it's a very big file, 30 megabytes. And this here is the file, I think this data. I have opened it with a text editor, and here you see all the information about this image, more information than I ever want to have, I think. That was it for today. I have not much time at the moment because I have to fix the schedule in my school, and for that I'm sure I have left a lot of outtakes in the file, and perhaps if you notice such a blunder, just imagine it's an outtake which is included in the show and not appended at the end. I hope to see you around next Thursday, and I hope that I can put a show out then. Bye bye.
Photocastnetwork.com, your photography resource in the potosphere. Photocastnetwork.com